Have you ever looked up at the night sky and wondered what remains hidden in the vast, velvet stretches between the stars? For centuries, our understanding of the cosmos has been dictated by light, the shimmering glow of distant suns, the swirling neon gases of nebulae, and the majestic spiraling arms of galaxies that illuminate the dark like lanterns in a forest. But what happens when the most famous telescope in history, the Hubble Space Telescope, points its sharp lens at what appears to be a total void and discovers something that challenges the very definition of a galaxy? This is the reality of Cloud-9, a celestial phantom that exists 14 million light-years away and possesses the gravitational weight of 5 billion suns, yet does not contain a single star to announce its presence. We're standing at a crossroads in the history of astronomy, witnessing a fundamental transition from observing the light to mapping the shadows that truly govern the universe. Imagine a region of space so massive that it can anchor entire clusters of galaxies through its sheer gravitational pull, yet it remains completely invisible to the naked eye and traditional telescopes, acting as a ghost in the cosmic machine. This find represents more than just a new object on a map. It is a profound reconciliation between what we see and what the laws of physics tell us must exist according to our most advanced mathematical models. As the legendary astronomer Carl Sagan once noted during his poetic explorations of the cosmic ocean, "We are like dwellers on a tiny island looking out across vast and dark waters, trying to decipher the mysteries of the deep." In this analogy, Cloud-9 is the hidden reef that we cannot see from the surface, yet it is the structure that determines the currents and the waves of the visible universe flowing all around us. For Professor Brian Cox, meaning is an emergent property of the universe that only arises where complex biological systems exist to perceive it, making Cloud-9 a vast, meaningless void of cold gas and dark matter, the ultimate counterpoint to our own star-rich and life-bearing neighborhood. The mystery deepens when we realize that if a structure of this immense magnitude can remain hidden so relatively close to our own galaxy, it forces us to ask what else is lurking in the profound darkness of deep space that we have yet to unmask. This discovery is the first tangible step toward unearthing the dark matter bones that provide the scaffolding for everything we can see, proving that the universe is built upon an invisible architecture that does not require the fire of stars to maintain its integrity. Cloud-9 is not merely an astronomical curiosity. It is a piece of impossible evidence that validates decades of theoretical work regarding the dark side of our reality, serving as a fossil from the early universe that has been preserved in a state of suspended animation since the epoch of reionization. The scientific significance of this starless cloud, formerly known as a Reionization-Limited H I Cloud or RELHIC, cannot be overstated, as it serves as the smoking gun for the Lambda Cold Dark Matter model but has dominated cosmology for a generation. By confirming that dark matter halos can exist independently of the stellar populations they were meant to harbor, Cloud-9 effectively rewrites our cosmic maps and changes the way we look at the emptiness between the stars. This detection was made possible through a remarkable synergy of global technology, combining the radio listening power of the 500-meter aperture spherical telescope in China with the sharp optical vision of Hubble's advanced camera for surveys. As we peel back the layers of this enigma, we are left with a haunting question. If the universe is indeed filled with these invisible structures, how much of our current understanding of cosmic history is based on a fundamental misunderstanding of the relationship between matter and light? Cloud-9 stands as a silent guardian of the void, a structure that possesses the mass of a galaxy but the luminosity of a shadow, and its discovery marks the moment when humanity finally learned to see the invisible bones of the cosmos. To truly appreciate the weight of the discovery of Cloud-9, we must first dive into nearly a century of scientific frustration and the relentless pursuit of the missing mass that has haunted astronomers since the early 20th century. The story of this invisible framework does not begin in a vacuum but is the culmination of a historical tension between what we can observe and what the mathematics of gravity demand. In the 1930s, the eccentric and brilliant Swiss astronomer Fritz Zwicky was studying the Coma cluster of galaxies when he noticed something that shouldn't have been possible. The galaxies were moving much faster than the visible matter in the cluster should have allowed. Zwicky was the first to propose the existence of dunkle materie, or dark matter, suggesting that there must be an invisible architect providing the extra gravitational glue to prevent these galaxies from flying apart like loose marbles on a spinning table. However, his ideas were so radical for the time that they were met with widespread skepticism, and for decades, the scientific community chose to believe that our eyes weren't deceiving us about the total mass of the universe. The tide finally turned in the 1970s and 80s thanks to the pioneering work of Vera Rubin, who examined the rotation curves of spiral galaxies and found that stars at the far edges were moving just as fast as those near the center. Rubin's data proved beyond a shadow of a doubt that galaxies are not just collections of stars, but are embedded within massive, invisible halos of dark matter that extend far beyond the visible light. Neil deGrasse Tyson often reminds us that dark matter is a profound misnomer because it implies that we know it is matter at all, when in reality, we are observing dark gravity, an effect without a visible cause that represents approximately 85% of all the gravity in the cosmos. Despite this realization, for the last 50 years, every concentration of dark matter we found was always associated with a luminous galaxy, leading to a holy grail search for a pure dark matter structure that had never been polluted by the birth of stars. This persistent gap between theory and observation led to the missing satellites problem, where computer simulations suggested that large galaxies like the Milky Way should be surrounded by thousands of small dark matter halos, yet we could only find a few dozen small dwarf galaxies. The discovery of Cloud-9 acts as the bridge between these abstract mathematical simulations and the physical reality of our local universe, proving that these missing satellites aren't actually missing. They are simply starless and silent. Scientists had long hypothesized that many of these dark matter halos were simply too small to form stars, or that the conditions of the early universe had halted their growth. But they remained theoretical phantoms until the world's most powerful instruments were turned toward the coordinates of Cloud-9. This history is a testament to the fact that in the world of science, some of the most revolutionary discoveries are the ones that confirm exactly what we cannot see. Cloud-9 satisfies the gravitational requirements of a major galaxy while maintaining the pristine invisibility of a primordial void, finally giving a face, or perhaps a shadow, to the invisible architect that Fritz Zwicky first glimpsed nearly 100 years ago. By solving this historical discrepancy, Cloud-9 validates the Lambda Cold Dark Matter model and offers a rare glimpse into the raw, unadorned mechanics of the cosmos, stripped of the distractions of starlight and stellar evolution. The identification of Cloud-9 as a starless failed galaxy was not a simple feat of observation, but required a masterfully coordinated multispectral methodology that pushed the boundaries of modern astronomy. The journey began in 2023 with the 500-meter Aperture Spherical Telescope, or FAST, which is nestled in a natural karst depression in the Guizhou province of China. As the world's largest single-dish radio telescope, FAST was designed to pick up the incredibly faint 21-centimeter radio signals emitted by neutral hydrogen gas across the vastness of space. While mapping the outer fringes of the spiral galaxy Messier 94, FAST astronomers identified a compact and remarkably spherical concentration of gas that appeared to be drifting in total isolation, far from any known stars or galactic structures. This was a tantalizing hint of a hidden structure, but radio waves alone are like hearing a sound in the dark without being able to see what made it. They revealed the mass and velocity of the gas, but could not confirm if the cloud was truly starless. To solve the mystery, an international team of researchers led by Gagandeep Anand and Alejandro Benitez Lambay secured time on the Hubble Space Telescope, utilizing its legendary advanced camera for surveys to peer into the heart of the cloud. Between February 17th and 19th, 2025, Hubble performed deep optical imaging of the region, using specialized filters to search for the specific light signatures that even the smallest and oldest stars would leave behind. The methodological rigor applied to this search was absolute, as the researchers constructed a color magnitude diagram to analyze the evolutionary tracks of any potential stellar populations. When the data was finally processed, it revealed a startling reality. The region was a total void of stars, allowing the team to rule out the presence of a luminous galaxy with 99.5% confidence. Before Hubble's intervention, it was possible to argue that Cloud-9 was merely a faint dwarf galaxy whose stars were too dim for ground-based telescopes, but Hubble's superior sensitivity nailed down the fact that this object is a pure relic of the dark universe. This discovery represents a pinnacle of instrumental synergy, as the radio data from FAST, the Very Large Array, and the Green Bank Telescope were combined with Hubble's optical precision to create a complete physical profile of the object. While the radio dishes detected a diffuse magenta glow representing 1 million suns worth of hydrogen gas, the Hubble images showed nothing but a deep field of background galaxies billions of light-years further away, highlighting the impossible contrast of Cloud-9. This methodology allowed scientists to calculate that for the cloud to remain so perfectly spherical and stable, it must be held together by an invisible anchor of dark matter totaling 5 billion solar masses. This cooperation between the world's greatest radio ear and its sharpest optical eye has provided a comprehensive look at an object that light forgot, proving that the silent guardians of the void can no longer hide from the combined might of human technology. The success of this methodology opens a new chapter in the hunt for failed galaxies, moving us away from the study of what glows and toward a more profound understanding of the dark matter bones that truly hold the universe together. Cloud-9 is an architectural masterpiece of the invisible world, possessing a physical configuration that is both rare and deeply revealing about the nature of dark matter dominance. While a typical galaxy like our Milky Way is a complex mixture of dark matter, billions of stars, and vast clouds of dust, Cloud-9 is a purest structure composed almost entirely of invisible material. The core of the object consists of a compact sphere of neutral hydrogen gas that spans roughly 4,900 light-years in diameter, which is about 5% of the width of the Milky Way. Within this relatively small volume, astronomers have measured approximately 1 million solar masses of hydrogen gas, a figure that would normally be associated with a small globular cluster or a tiny dwarf galaxy. However, the true enigma of Cloud-9 lies in the staggering imbalance between this visible gas and the dark matter that encapsulates it. For this cloud of gas to maintain its highly spherical shape and resist the urge to disperse into the surrounding intergalactic medium, it requires a massive amount of gravitational containment. Using the principle of hydrostatic equilibrium, where the outward thermal pressure of the gas is perfectly countered by the inward pull of gravity, researchers have calculated that Cloud-9 resides within a dark matter halo of 5 billion solar masses. This means that for every single atom of visible hydrogen, there are 5,000 parts of invisible dark matter, a ratio that is significantly higher than what is found in normal, star-forming galaxies. It is this extreme dominance of dark matter that gives Cloud-9 its rigid, permanent structure, allowing it to act as a stable anchor in space that has remained unchanged for billions of years. If we were to visualize this, it would be like finding a massive, invisible planetary body that only reveals itself through the way it holds a thin, ghostly atmosphere in place. The stability of Cloud-9 is further evidenced by the fact that it shows no signs of rotation or internal turbulence that would suggest a recent collision or galactic interaction. Most gas clouds floating in the proximity of large galaxies are shredded by tidal forces or blown apart by the intense radiation and winds from nearby stars, but Cloud-9 is a quiet, non-spinning behemoth that refuses to be disrupted. This architectural rigidity suggests that we are looking at a pristine dark matter halo that has been frozen in time since the earliest eras of the universe. By studying how the gas is distributed within this invisible cage, physicists can map the density profile of the dark matter itself, checking if it matches the cuspy predictions of the cold dark matter model, or if it suggests something even more mysterious about the nature of the dark universe. Cloud-9 is not just a cloud. It is a macroscopic manifestation of the gravitational bones of the cosmos, providing a rare and clean environment where we can observe the raw mechanics of gravity without the messy interference of stellar evolution. The reason Cloud-9 stands today as a starless ghost instead of a brilliant island of stars is rooted in the violent thermodynamics of the early universe and a period of cosmic history known as the Epoch of Reionization. Approximately 13 billion years ago, the universe underwent a massive phase transition when the first generation of massive stars and quasars began to flood space with intense ultraviolet radiation, a process that burned through the neutral hydrogen fog of the cosmic dark ages. For a cloud of gas to become a galaxy, It must be able to cool down and collapse under its own gravity, radiating away its heat until it becomes dense enough to ignite nuclear fusion. However, during reionization, the cosmic ultraviolet background acted as a universal space heater, stripping electrons from hydrogen atoms and raising the temperature of the intergalactic gas to between 10,000 and 20,000 Kelvin. This intense heating created a fundamental tug-of-war between thermal pressure pushing out and gravity pulling in, and for smaller structures like Cloud-9, the heat of the universe won the battle. In a massive galaxy like the Milky Way, the gravitational pull was so overwhelming that it could force even this hot, reionized gas to collapse and form stars, but Cloud-9 was caught in a scientific sweet spot. Its dark matter halo was heavy enough to prevent the gas from evaporating and flying away into the void, yet it wasn't quite massive enough to force the gas to overcome its own thermal energy and collapse into stars. This state of permanent stalemate is what defines a Reionization-Limited H I Cloud, creating a celestial object that is essentially a failed galaxy preserved in a state of thermal equilibrium with the background radiation of the universe. Because Cloud-9 never formed stars, it remains a primordial time capsule containing hydrogen gas that has never been processed or polluted by the heavy elements created in stellar furnaces. While every atom in our bodies, the carbon in our cells and the iron in our blood, was forged inside the hearts of dying stars, the gas in Cloud-9 is exactly as it was just moments after the Big Bang. Studying this failed galaxy allows astronomers to measure the temperature and intensity of the radiation that filled the entire universe 13 billion years ago, providing a direct link to the conditions of the infant cosmos. It is a haunting thought that the very first stars to ever shine in the universe are the ones that effectively suffocated the potential of Cloud-9, using their radiation to prevent this 5 billion solar mass structure from ever becoming a home for stars of its own. Cloud-9 is thus a silent witness to the moment when light first conquered the darkness, a fossil leftover that reminds us of the billions of potential galaxies that were snuffed out by the birth of the first stars. For over 30 years, one of the most glaring problems in our understanding of the cosmos has been the missing satellites problem, a discrepancy that threatened to collapse the prevailing Lambda Cold Dark Matter model. When scientists used supercomputers to simulate how dark matter should clump together to form the structure of the universe, the math always predicted that large galaxies like the Milky Way should be surrounded by thousands of smaller dark matter halos. However, when we looked through our telescopes, we only found a few dozen small satellite galaxies, leading to a frantic search for where the rest of these structures could be hiding. Some suggested that our understanding of dark matter was fundamentally flawed or that gravity worked differently on smaller scales. But the discovery of Cloud-9 has finally provided the missing link that validates the simulations. Cloud-9 is the first confirmed piece of evidence that the universe is indeed teeming with these missing satellites, but they have remained undetected because they are entirely starless and silent. It proves that dark matter halos can form and persist across billions of years without ever harboring a single star, effectively solving the paradox by demonstrating that the dark matter infrastructure is present even when the luminous inhabitants are absent. This discovery has profound implications for our understanding of the cosmic web, the vast network of filaments that defines the large-scale structure of the entire universe. We now know that the visible galaxies we see are merely the lighted intersections of a much larger, darker network, and Cloud-9 represents a node in that network that remained dark, a silent guardian that has been part of our cosmic neighborhood since the beginning of time. This find shifts the focus of cosmology from a hunt for galaxies to a hunt for dark matter halos, as we begin to realize that the vast majority of the universe's structural diversity is hidden in the deep shadows. Furthermore, Cloud-9 serves as a crucial benchmark for the efficiency of galaxy formation, helping us understand the exact mass threshold required for a structure to transition from a dark cloud into a shining island of stars. By studying the properties of this failed galaxy, astronomers can refine their models of how the very first stars were born, using Cloud-9 as a baseline of minimalist structure against which more complex systems can be measured. As the researcher Alejandro Benitez Lambe noted, we often learn more from our failures than from our successes, and in the case of Cloud-9, a galaxy that failed to form has become the most important key to understanding why the rest of the universe looks the way it does. Cloud-9 is located in the celestial backyard of one of the most beautiful and well-studied galaxies in our local universe, Messier 94, a dazzling spiral galaxy in the constellation Canes Venatici. This proximity is far more than a simple visual coincidence. The research indicates a real physical association between the starless cloud and the massive spiral galaxy. Located approximately 14 million light-years from Earth, Cloud-9 shares a position in our local volume of space that matches M94, and its recessional velocity, the speed at which it moves away from us due to the expansion of the universe, is nearly identical at 300 kilometers per second. This shared velocity suggests that Cloud-9 is gravitationally bound to the environment of M94, acting as a ghostly companion to its star-rich neighbor. The association with M94 was actually instrumental in the detection of Cloud-9, as its proximity to such a well-known object allowed astronomers to narrow down their search and look for subtle gravitational interactions. High-resolution radio data from the Very Large Array has revealed slight gas distortions and ripples in Cloud-9, which suggests that the massive gravity of M94 is exerting a tidal pull on the cloud, or that it is suffering the effects of ram pressure stripping as it moves through the thin, gaseous halo surrounding M94. This interaction is of immense interest to scientists because it allows them to study how a pure dark matter halo behaves when it is subjected to the external forces of a larger neighbor. Unlike the fragile stars of a typical dwarf galaxy, the gas in Cloud-9 is held remarkably tight by its 5 billion solar mass dark matter core, showing a level of resilience that would be impossible without such a massive invisible anchor. The existence of Cloud-9 near M94 also raises the chilling possibility that every major galaxy, including our own Milky Way, is surrounded by these invisible ghosts. We may be living in a crowded neighborhood of abandoned houses, starless failed galaxies that have been lurking on the outskirts of every spiraling star system we've ever cataloged. Cloud-9 happened to be the first one large enough and close enough to be unmasked by our current technology, but it likely represents a vast and hidden population of similar objects. Messier 94 itself is a fascinating object of study, with its 40 billion stars and intense starburst rings, but the discovery of its dark neighbor reminds us that the most significant parts of a galactic system may be the ones that do not shine. As we continue to monitor the relationship between M94 and Cloud-9, we are gaining a rare look at the interplay between the visible and the invisible, seeing how the light of a major galaxy is anchored by the silent bones of the dark universe. In the grand hierarchy of the cosmos, there is an invisible dividing line between a simple cloud of gas and a true galaxy, and this line is defined by a critical mass threshold. If a dark matter halo is above this mass, its gravity is strong enough to compress gas and ignite the fires of nuclear fusion. If it is below, it remains a starless RELHIC. Cloud-9 is scientifically miraculous because it sits exactly on this razor's edge, representing the absolute minimum scale at which a structure can retain its primordial gas without ever forming a single star. Theoretical models of the Lambda Cold Dark Matter framework suggest that this threshold is approximately 5 billion solar masses, exactly the mass that has been measured for the invisible anchor of Cloud-9. This makes Cloud-9 a boundary object, a rare and precious find that represents the most precise ruler ever discovered for measuring the efficiency of the universe's star-forming machinery. If Cloud-9 had been just slightly more massive, its internal gravity would have won the battle against the cosmic heating of the early universe, and it would have collapsed into a recognizable dwarf spheroidal galaxy similar to the ones we see orbiting the Milky Way. On the other hand, if it had been even slightly smaller, the intense ultraviolet radiation of the early universe would have stripped its gas away entirely, leaving behind a nude and indetectable dark matter halo. Its survival as a gas-rich but starless cloud is a perfect sweet spot of cosmic evolution, a monument to the delicate balance between the heat of the Big Bang and the pull of gravity. By studying this threshold, astronomers are effectively taking the temperature of the infant universe 13 billion years ago, as the existence of Cloud-9 depends entirely on the intensity of the radiation that filled space during the epoch of reionization. This creates a fascinating cycle of feedback. The first stars in the universe created the radiation that prevented Cloud-9 from becoming a star itself, And now, by measuring Cloud-9, we can calculate the strength and impact of those very first stars. Cloud-9 is thus more than a failed galaxy. It is one of the most successful tools we have for reconstructing the history of the early cosmos. It stands on the knife edge of existence, a silent witness to the moment when the laws of thermodynamics decided which parts of the universe would shine and which would remain forever in the dark. To truly understand why Cloud-9 has caused such a stir in the scientific community, we must distinguish it from other celestial objects that might appear similar at first glance but are fundamentally different in their nature. Over the years, astronomers have identified several candidates for dark galaxies, but none have met the strict criteria of a RELHIC as perfectly as Cloud-9. For example, there are high-velocity clouds found near the Milky Way, which are massive clouds of neutral hydrogen that contain no stars. However, these clouds are typically irregular, shredded by galactic interactions, and lack the massive dark matter halos required for long-term stability. Cloud-9, by contrast, is compact, highly spherical, and self-gravitating, indicating that it is a permanent and ancient structure rather than a passing wisp of gas. Cloud-9 must also be distinguished from other dark galaxies like FAST J0139, which was previously hailed as a similar discovery. While those objects often show rotational support, indicating they have collapsed into a disk and contain millions of solar masses of gas, they frequently have weak limits on their stellar content. Cloud-9 shows absolutely no rotation and has a definitively starless core according to the 99.5% confidence limit established by the Hubble Space Telescope. It is also distinct from ultra-faint dwarf galaxies, which are the dimmest known galaxies containing only a few hundred stars. Those are the successes that barely manage to form stars, whereas Cloud-9 is the next step down, the failure that never made it at all. The most crucial differentiator for Cloud-9 is its pristine, primordial state, as it consists of hydrogen gas that has never been processed by a star. Most gas clouds in our local neighborhood have been polluted by elements like oxygen, carbon, and iron created in the hearts of previous generations of stars, but Cloud-9 is believed to consist of the original material created in the Big Bang. This makes it a living fossil of the chemical composition of the early universe, an object that has remained untouched and unpolluted for over 13 billion years. While other objects are the result of galactic debris or failed star formation in smaller halos, Cloud-9 is a pure manifestation of the raw infrastructure of the universe, providing a window into a time before the first light changed the chemical makeup of the cosmos forever. Cloud-9 is far more than just an astronomical curiosity. It is a dedicated natural laboratory for testing the fundamental laws of physics in an environment that is virtually impossible to replicate on Earth. Because the object is a simple system, composed almost entirely of dark matter and a small amount of gas, it provides a clean environment for observation. In a typical shining galaxy, the movement of gas and stars is complicated by what scientists call stellar feedback, which is the explosive energy of supernovae and the powerful winds from young stars. This constant activity creates a tremendous amount of noise that makes it incredibly difficult to measure the underlying dark matter with any real precision. In the quiet, starless heart of Cloud-9, there is no such noise, as the gas moves exclusively in response to the gravity of the dark matter and the pressure of the cosmic background radiation. This allows physicists to map the distribution of dark matter with unprecedented accuracy, helping to answer one of the biggest questions in modern science. Is dark matter cuspy, dense at the center, or chord, spread out evenly? The answer to this question could rule out certain candidates for dark matter particles, such as weakly interacting massive particles or self-interacting dark matter, and fundamentally change our understanding of the subatomic world. Cloud-9 is a macroscopic manifestation of the tiny quantum fluctuations that existed at the beginning of time, frozen for us to study 14 million years later. Furthermore, Cloud-9 offers a unique opportunity to test if Einstein's general relativity holds up at these scales of extremely low density, or if modified Newtonian dynamics provides a better explanation for the gravity we observe. We are looking at the raw mechanics of the cosmos, stripped of the distractions of light and nuclear fusion, allowing us to see how matter and gravity interact in their most basic form. Cloud-9 is the subject of tests for theories that range from the nature of the Big Bang to the final theories of Stephen Hawking, acting as a bridge between the smallest particles and the largest structures in the universe. As we study this failed galaxy, we are not just looking at a cloud of gas, we are looking at the very rules that the universe uses to build itself, providing a rare and pristine window into the hidden physics that governs our reality. The discovery of Cloud-9 by the Hubble Space Telescope is only the beginning of a much larger story, and the next phase of this research will utilize the unprecedented power of the James Webb Space Telescope. While Hubble has confirmed that there are no visible stars, the James Webb Telescope is uniquely equipped to look for the invisible heat signatures and thermal fingerprints that other telescopes simply cannot detect. One of the primary objectives for the upcoming Webb observations is to measure the exact temperature of the gas within Cloud-9 using infrared spectroscopy. This will confirm if the cloud is truly in thermal equilibrium with the cosmic ultraviolet background, providing a direct measurement of the radiation field that filled the infant universe 13 billion years ago. Beyond temperature, the James Webb Telescope will also search for the presence of brown dwarfs, failed stars that were too small to ignite nuclear fusion, which would reveal if the star formation process in Cloud-9 failed completely or just mostly. We also plan to use Webb's infrared eyes to perform a chemical analysis of the gas, searching for any traces of heavy elements. If the gas is found to be zero metallicity, it will definitively prove that Cloud-9 is an untainted relic of the Big Bang. But the hunt does not stop at Cloud-9, as astronomers believe this object is merely the tip of a vast cosmic iceberg. If we have found one such object so close to us, it stands to reason that there are dozens, perhaps hundreds, of other failed galaxies lurking in our own local group. Future surveys using the VERA-C Rubin Observatory and the Nancy Grace Roman Space Telescope will scan the entire sky for the ghostly signatures of these RELHICs, eventually allowing us to create a complete, dark map of our cosmic neighborhood. We are entering an era where we no longer just look at the things that glow to understand the universe, but look into the deep darkness to see the structures that truly hold everything together. As Brian Cox often reflects, the universe is a vast and ancient machine, and we are just beginning to understand the hidden components that make it work. Cloud-9 is a reminder that the most significant parts of our reality may be the ones that do not shine, and it challenges us to look deeper into the void. For it is in the darkness that the true secrets of our origin are hidden. The final confirmation of Cloud-9 stands as the first definitive evidence of a failed galaxy, proving that the structure of the universe is built upon a foundation of dark matter halos that do not require stars to exist. By unmasking this invisible structure, we have taken a giant step toward solving the missing satellites problem, demonstrating that the ghost galaxies predicted by our simulations are real and present in our local universe. With 5 billion solar masses of dark matter and only 1 million solar masses of gas, Cloud-9 represents a state of near-perfect dark matter dominance, serving as a pristine laboratory for the new physics of the future. This discovery honors the legacy of Carl Sagan, who taught us that extraordinary claims require extraordinary evidence. Hubble's 99.5% confidence limit provides exactly that, transforming an impossible idea into an observed reality. Just as Stephen Hawking showed that black holes are not truly empty, but possess complex properties, Cloud-9 shows that the voids of space are not empty, but are filled with the primordial architecture of the Big Bang. As a relic of the epoch of reionization, this cloud offers us a direct link to the conditions of the universe 13 billion years ago, preserved in a state of suspended animation like a message in a bottle from the dawn of time. The upcoming missions with the James Webb Space Telescope will peel back the final layers of this enigma, but the philosophical reflection is already clear. Cloud-9 forces us to reconsider our place in the cosmos. If the majority of the universe is made of such dark and silent structures, then our star-filled sky is not the rule, but a beautiful and luminous exception. We are the way the universe knows itself, and through discoveries like Cloud-9, we are finally learning to see the parts of the universe that have no eyes to see us back. This journey to understand the dark matter bones of our cosmos is the journey to understand our own deepest origins, hidden in the places that light forgot to shine. As we continue to gaze into the void, we find that the darkness is not a void at all, but a rich and complex landscape filled with the fossil remains of the infant universe. Cloud-9 is a silent witness to our history, a ghost that has finally been caught in the light of human curiosity, and its story is only just beginning to be told. The future of astronomy lies in the shadows, and by learning to see the invisible, we are finally coming to understand the true and complete mirror of the cosmos.